So this question was kind of confusing. Page 381, number 61. We're taking a random variable from the same group. Okay, so if we take them from the same group, it should have the same mean and the same standard deviation. So in other words, we take two cars and it would have 1.4 for the emissions, a standard deviation of 0.3. And the other car should also have the same, because we're taking it from the same group, 0.3. Okay, and they say, well, what if we take the two cars at random and we subtract them? Well, overall, if we did this a whole bunch of times, we should come up with a new standard deviation of 0, or approximately 0, if we subtract these two things. Okay, and then the new standard deviation, you probably know this now, you are going to square them and add them and then take the square root. So the new standard deviation is going to be, whoops, let me write that down. So there's our new stuff. Now, they happen to take two cars and they have a difference in their emissions of 0.8 and are saying, is that surprising? Well, let's see. You could take two cars and subtract them, car 1 minus car 2, and you get a difference of 0.8. But you could also happen to take car 2 minus car 1, and that would give you a difference of negative 0.8. So we have to do the z-score twice, and this is what it's going to look like. We're interested in 0.8, right, the difference, minus our new standard deviation divided by, or new mean, divided by the new standard deviation, which is 0.4243, and we get 1.89. Now, what if we subtracted them the other way, and then it would be the negative 0.8 minus 0 divided by 0.4243, and you might guess that that would be negative 1.89. Okay. So in other words, we're kind of looking at this. It just makes more sense to me when I draw a graph. So 1.89 on either side, the low and the high. Like that. We're trying to figure out these two areas together, added together. So if you do normal CDF for this and normal CDF for that, probably going to get the same thing for both of them. And I think it's 0.0294. 0.0294. That's that area under the curve on both sides. And then if we add them together, we should get 0.5, what was it? 0.5, oh wait, no, 0.0588, 0.0588. Okay, so in other words, the situation would be, if we took two cars at random and subtracted them, the fact that they would have an emissions of difference of 0.8, well, there would only be about almost a 6% chance that that might happen. Okay, is that surprising? I think a little bit. Okay, so there we go.